Greetings everyone, this is non-expert here back again with another video. Today we are going to be solving problem number 65 and the difficulty it's been rated at is easy. This problem was asked by Amazon and I've seen this problem being asked by a lot of startups as well and also by Microsoft. So the problem description is that given a n by n matrix of numbers, you need to print out the matrix in a clockwise spiral. So you've been given an example over here where you have a matrix um, from 1 to 20 and you can see that the number of rows is not equal to the number of columns, and the way you want to print out the output is that you want to go in a spiral clockwise way. So basically you want to go from left to right in the beginning, then top to bottom, which is going to be 5, 10, 20, 15 and 20, so you can see that over here. Then after that you want to go here, which is right to left, then again bottom to top, and then so on and so forth. So you keep on going like in a spiral way, and if you sort of trace this thing out, you can see the spiral thing coming out as well. So fortunately we were able to find a similar problem on LeetCode, and the name of the problem is spiral matrix. Before we start with this problem, although this problem is a little easy, if you know how to do it, it can be a little bit tricky based on what all complexities are you dealing with. So today, since it's not been given in the problem description, we're going to be assuming that there is no issue with space complexity whatsoever. And you might want to like talk to your interviewer about that stuff because you know the time complexity should not exceed more than big O of m cross n because you have to go through all the elements, right? But for the space complexity, since that's not been talked about, you can sort of talk to your interviewer about whether there are any restrictions there, and if there are no restrictions whatsoever, this problem becomes a lot more easier. If there is a restriction and you want to do this in O of 1, I'll talk about the solution. I'll try to jot it down a little bit, but the main idea behind how you would want to sort of solve it will sort of still revolve around the same idea. Cool. So as we sort of talked about, if you sort of take this particular area or sort of this particular matrix, you know that you're going to go from 1 to 3 first, then 6 and 9, then 8 and 7, then 4 and 5. So that's your spiral way of you traversing through everything. One thing that you might want to notice over here is that you want a way to control your directions, and that's something that we'll be doing. And you would want to control your ith and jth values as well. Cool. Keeping those things in mind, let's start off with the solution. And again, the best way to start with the solution is start with the base conditions. So the base condition could be as simple as you saying that, hey, if there's no matrix, then return a simple list or whatever. Yeah. Do note over here that you're not printing out the values, you're returning them as a list. So we're going to keep a value, we're going to call it as result, and we're going to make it a list. So as you're going to be traversing through each and every single element in the spiral way, we're going to be appending those values inside our result. So let's do that return result, and inside this particular block, we're going to be putting in our logic. So one of the most important things is that you want to control your ith and your jth values, and that's pretty obvious because you want to know at which ith and jth value you're presently at. Most people, the mistake that they probably do is that they put the ith and jth element inside the for loop. Over here, we're not going to be doing that. So that's one thing that we need to sort of take care of. And the other thing that you want to take care of is the direction. So we're going to have direction underscore I and direction underscore j, and we're going to give it some values. We're going to give 0 and 1. Okay, so a brief description of why I'm doing 0 and 1 over here. So as you know, for the first iteration, we're basically going from left to right. So when you go left to right, if you sort of update your directions, like if you do I plus direction of I and I plus equal to direction of j, oh sorry, j plus equal to direction of j, what you're doing is in essence you're just updating those values. Um, and over here, as you know, you're going to be going either left to right or top to down or bottom to top or right to left. So when you go from left to right, ideally what you're doing is you're just incrementing the jth value. So that's what we're going to hone in inside a direction J. Whenever we sort of come to a value where we've already processed something, we're going to update our direction J and we're going to update the direction I with it as well. So as you know, as you can see over here, whenever you're going from left to right, after you're done with that entire iteration, you're supposed to go top to down. So that's just going to be an update on the direction I. And there's a very easy way of doing this. So I'll do that, and then I'll sort of explain what exactly is happening there as well. Cool. So let's do a quick for loop, and we're going to do a for loop of m cross n. I need to define my m and n, so let's do that real quick. We'll do m is equal to length of your matrix. Whoops. Sorry. Yeah. And n would be the length of your, I mean, the number of columns that you have. So you're going to be iterating through all those values. And one thing which I sort of already talked about is that if you know that the space complexity, I mean, there are no issues with the space complexity, you can just, put a dictionary here where we're going to control for the ith and jth values which have already been seen. So now what we need to do is, the very first thing is that we update the value of result and we append the ith and jth value of the matrix. So we do that, we'll do matrix I, comma j, or I and j. And now what we need to do is we need to sort of make sure that the value that we sort of process right now sort of goes inside our dictionary. So let's do that. And as you know, dictionaries are good at handling tuples as it's hashable, so we'll do that. And the next thing that you want to take care of is that you want to check whether things are going out of bounds or not. And that's pretty simple to do as well. So ideally what you want to do is you want to check whether the next element that I'm going to go to, whether that value exists inside my scene or not. So in a way, what we're going to be doing is we're going to check whether the next value, which is going to be I plus direction of I, and we're going to put modulus of m over here so that we don't go out of bounds on the matrix itself. And the jth value, which is j, the next jth value, which is going to be j plus direction of j, modulus of n. Whether that thing, oh, I'm sorry, I don't know why I put 4 over there. That's my fault. Yeah. So if this particular value, which is the next value, which is going to be updated, is already inside scene, we need to update our directions, because ideally what you're doing is, now that you've traversed through all the values which you already have, you've you're basically like doing a round trip, and you're going to the same element which you've already traversed through. So if that happens, you need to make sure that you're updating your directions and then sort of moving forward with that. So this is a little trick, and sort of talk about why exactly I'm doing this thing. So you're basically updating the direction I with direction J, but in a smart way. So you do direction I is equal to direction of J, and direction of J is going to be negative of direction of I. And some people might be confused by this, but it's pretty simple. The logic is that if you go from, so let's take a step back. So when we say that we have to go from left to right in the beginning, we've done that. Then we go from 6 to 9, which is top to down. But after we're done with this top to down, we need to make sure that we're going from right to left rather than left to right. If we don't update the negative value, we're going to go to the rightmost value, and then it's just going to go recursively from there. But we don't want to do that. We want to make sure that we're going from right to left now. And when we go from right to left, the next thing is not top to down, it's bottom to up. So basically you're updating those values accordingly, and that's where this negative thing sort of comes into play. And now, if that thing happens, you need to obviously update your ith and jth values, which we sort of already talked about, and you're basically done. So again, all you've done over here is that you've sort of made a dictionary which sort of looks at all the values which you've already traversed, and you make sure that you're not updating just the values inside result. And if you sort of go through the same value which you've already traversed, you want to make sure that your direction I and your direction J are getting updated accordingly. And this sort of makes sense as well, because when you have 1 to 3, you go 6 to 9, you go 8 to 7. You don't want to go from 4 to 1 next, right? Because 1 has already been traversed, you want to go to 4, and then you want to switch up. So that switching thing will sort of take place due to the scene. Um, and that's basically it. Let's just run this real quick. Hopefully this should run fine. And again, if you don't really understand, the main essence of this entire logic is just it sort of revolves around this particular directions and how you're sort of updating those things. It's pretty simple to understand it if you sort of do a trace through, but it's pretty simple. You can see that the expected output is the same as the actual output. So let's just go ahead and submit this. Hopefully this should run fine. And awesome, you can see that, it's faster than 97 of the Python online submissions, and that's pretty awesome. And the reason for that is, of course, just because of the scene and the way we sort of handled some of the things. But there is one more way which I sort of talked about, which is the memory restriction way. So if your interviewer says that, hey, you can't really update, or you sort of can't really go through, okay, or rather you cannot sort of keep a dictionary where you're sort of updating all those elements and the space complexity needs to be O of 1. That can be a little bit tricky, but overall the logic sort of revolves around the same thing. So we already talked about how you would want to update your directions. The other thing which you sort of already know about is that, hey, if I've already traversed through this particular row, I don't need it anymore, right? So the way we can sort of do that, and we'll do that real quick, is that you want to make sure that you have a window. So if I've already traversed through this particular item, I want to make sure that that thing is not being considered anymore. So basically you can have, and that logic sort of revolves around you having a left partition, a right partition, and a bottom as well. So basically restricting the window as you sort of going forward. So we'll quickly do that. We'll do left, top, right, bottom, and we'll update all these values to be something that we can sort of work with. And this is pretty simple. If you don't understand what I'm doing over here, don't worry about it. All you're doing is you're just going to update your left value after you're sort of done with this particular guy. You're going to update your right or your top value as you're sort of done with that, and you keep on incrementing those things. So whenever you sort of go through this particular item, your top is going to be updated accordingly. Um, and yeah, and that's basically it. So the reason why I sort of don't really like this problem is because it sort of messes up with a few things. Because you need to handle four different if conditions, and I'll quickly do that because I've sort of already done it in a way. But you want to look at each particular direction that you're sort of going into. So if you're going from left to right, which would be direction, sorry, if you're going from left to right, it would be direction j equal to 1, which we know, which we've already sort of talked about. Then you sort of need to make sure that you're not going out of bounds. So you do j plus direction of j is, if it's greater than equal to the rightmost value, then you want to stop your iteration, because if you're going from 1 to 3, the only reason why you'd want to stop is because there is a restriction held on the rightmost value. So if you're updating to something which is the rightmost value, then you need to swap out the thing. So I'll just copy paste our condition, um, and um, also update our topmost value as well, because basically you're done with this iteration, so you need to update top, and you do top plus equal to 1. Oops. Oh, sorry. So yeah, and then you need to do this like 4 more times. And that's the reason why I sort of don't like this, because this problem just becomes complicated without any reason. The main essence of the problem then becomes that how good are you at handling if-else conditions? And that's, for me, that's just a little dumb. I mean, it doesn't really make sense, but if the interviewer wants that, then you have to sort of go through it. So next thing that you would want to handle is that if your direction is from right to left, which would basically be um, over here when you go from 987. So when that happens, the restriction would be that, hey, when I've hit my leftmost value, then that's an issue for me, right? So that's something that you want to control for. So you'll say, hey, if the next value is less than equal to the left value, then do the update again. So we'll copy paste the guy that we sort of already talked about, which is update the directions again. Um, you can also update the directions in a simple way. I'm just copy pasting this so that we are on the same um, level. But yeah, you can update it as you sort of move forward with it. Yeah. So when that, sorry. So when that right to left happens, you want to restrict the bottom area now. So you decrement the bottom because the bottom is sort of M, and then you sort of want to go from there. So next thing would be you handle the top to down condition, which is going to be direction of I equal to 1, and if I plus direction of I is, so again you can sort of look at this, is 369. So you would stop when your value is going to be greater than or equal to the bottommost value. If it is, then you update the directions again. So let's copy this again. I know I'm copy pasting it over and over again, yeah. But yeah, so when it's sort of greater than or equal to bottom, then you want to restrict the rightmost value. And the last condition would be, hey, if my direction of I is equal to -1 and I plus direction of I is less than or equal to the topmost value, then update this guy and also restrict the leftmost value as well. So we'll do left plus equal to 1. So in a way, you're using the left, you're using the topmost, the left values, the right values, and so on and so forth, just so that you can, control for all these things. And basically, the essence just becomes that how you want to handle the if-else condition. You can sort of, optimize this thing to not update or swap those directions. But since I already talked about it, it becomes a lot more easier, and you can sort of see that if you sort of, work your way through the other way. So if you sort of go through the space complexity way where you don't have any restrictions so far, you can see that the problem was like pretty simple, right? Because you know that whenever there is an element which I've already traversed through, I don't want it anymore. So I just swap out all those values. Otherwise, what you're doing is just sort of constraining the limits of the matrix, and then you're sort of doing four reverse conditions. And obviously, you keep on updating the ith and the jth values, and that's basically it. So let's go ahead and run this. Yeah, let's just hope that this thing runs fine and I'm not missed out on any edge case. Yep, it seems to be running fine over here. Let's just go ahead and submit it. Hopefully this should run fine as well. Yep, and it's running fine. You can see that there's like literally no difference between how fast it's running and the the memory usage also seems to be exactly the same. The reason for that's pretty simple. It's just because you're sort of constraining all the things as you're sort of going forward. But yeah, and that's basically it. So again, few takeaways from this problem is just that you need to understand how you would want to handle directions. Whenever you look at a matrix problem, don't sort of think about how you would handle it in a for loop. Rather think about what's the best way of sort of approaching this problem. So that's the second takeaway. And the most important thing is how would you swap out the directions? And again, if you don't understand it, you can sort of trace through it. It's just that that negative value usually gets people, but once you update the negative value, you're good to go, you're done. And also, the last and the most important thing is just that if you have your result, you need to ask your interviewer about how the result is going to come through. If you're doing a simple print, then you can just make a print over here. Otherwise, you would just make a result. Everything else remains the same. If you have to go through the if-else condition, well, you can do that. That's okay, but it's going to take a lot more time. Yeah, and that's basically it. So thank you so much for watching this video. I really appreciate all your comments. I've been reading through them. I'll try replying to almost all of them as soon as I can. And also, I apologize for not being able to upload videos. I remember I promised in the last video that I'll be uploading every 2 weeks or so, but things have been a little busy. So I'll try to upload videos as soon as I can. It's going to be a lot more sporadic, but I'll try to push out videos as much as I can because I know the recruitment season is sort of coming along. But yeah, thank you so much for your comments. I really appreciate it. And if you've already subscribed to this channel, you're awesome. We all know it. And if you're not subscribed, do hit the subscribe button. Leave your comments if you didn't understand something, and do give a like. I really appreciate it. And thank you so much for your time. All right. Have a good day. Bye bye.